Welcome everyone. This video is to provide you with some helpful hints to guide you through which intermolecular force is associated with which substance. By now you should already know that there are 4 different types of intermolecular forces. We've seen molecule-ion attractions, dipole-dipole interactions, hydrogen bonds, and also dispersion forces. So the first possible hint that I could give you is to remind you that intermolecular forces are between 2 or more molecules. So even if you're given something like water, you don't want to imagine just one water molecule. Intermolecular forces are really the interaction of many. So in order to start this or to actually see the intermolecular force, we want to think of many of these things. So I'm going to draw a couple of them, or have a couple of molecules around one another. And by having these molecules around one another, then we can think about which intermolecular force comes into play. And when we deal with water, what we're actually dealing with is a hydrogen bond. And the guiding expression that we always use is opposites attract. So I have an intermolecular force, or I have a hydrogen bond between that positive or partial positive hydrogen of the left molecule to the partial negative of the bottom water molecule. And I could have an intermolecular force between this oxygen on the top, because it's partially negative, with that partially positive hydrogen. And we can continue doing this as many times as we see it. But the best way to see it is to actually have more than one molecule. Now, that second helpful hint that I possibly can give you is that you should draw a Lewis dot structure and/or assign molecular polarity first. By having the Lewis dot structure, 1, you can look at it, and then 2, you can actually assign molecular polarity. So if I was given H2, H2 has 2 hydrogens, and each hydrogen has 1 valence electron. So I have that molecule there. Some of you like to draw the structural formula, which is perfectly fine. And I'm going to follow hint 1. I'm going to draw several of these, because intermolecular force is really an interaction of many, not just one. Now, once I draw the Lewis dot diagram, I might not be sure exactly what intermolecular force this might be in or might have. So now I'm going to assign molecular polarity. When I look at the electronegativity of hydrogen, it's 2.2. And since I have 2 hydrogens, the electronegativity values are exactly the same. By taking the electronegativity difference, I have an E and D of 0. So that tells us that the bond between these 2 hydrogens is a non-polar bond. They share equally. Now, since H2 is a small molecule, not only does it have a non-polar bond, but it is also a non-polar molecule. By knowing the polarity of H2, that right away leads me to dispersion forces. Dispersion forces are the only type of intermolecular force that actually deals with nonpolar molecules. So it was helpful to know the molecular polarity of H2. Now, the last thing that I could give you to guide you is a dichotomous key. We tend to use dichotomous keys more in biology. I created one here for you to help you with intermolecular forces. Dichotomous generally means divided into 2. And a dichotomous key is really just a tool that asks a series of yes and no questions. And by having these specific yes and no questions, it leads me to the identity of what I want to know. And in our case, it leads me to which intermolecular force to use. So my dichotomous key for intermolecular forces just starts with a yes or no question. And the first question that I am going to write down is,